So, welcome to part 2 of section 2.3. This section, or this video, will primarily talk about the ambiguous case when dealing with the sine law. Okay, the ambiguous case when dealing with the sine law. This case will occur, well, first of all, the cases we had before, if you're given measures of two angles and one side like this, okay, then they're uniquely defined. Okay, there are a few other instances when we have things that are uniquely defined. If you have this situation, a side-side angle situation, where you're given two sides and an angle opposite one of those sides, then the ambiguous case might occur. There are three possibilities here. Here they are right here. No triangle can possibly exist. One triangle will exist, or two distinct triangles will exist. So, I go through in the notes the different cases that can occur. So for instance, if you're in triangle A, B, and C, okay, back from over here, and you know you're given B and angle A, if angle A is acute, four different possibilities will happen. If angle A is obtuse, three different possibilities will occur. And you can go through and look at what I wrote or what I drew. But here's a summary of it for our purposes here. Here's a summary of both of those cases. Okay, so this is when angle A is acute, and this is when angle A is obtuse. If A is greater than B or greater than or equal to B, one solution, and so on and so forth. You can see what we're going to do is we're going to first test out, given the information we have, how many solutions there'll be. If there's no solution, then there's nothing we can do. We're going to be done. If there's one solution, we're going to find that solution. And the case I'm going to go over, if there are two solutions, then we'll find both of those. Okay, I think we're going to go over that one. Let's see what practice problem arises. Certainly this first question right here, there are two solutions, and you can go through. You're going to see how I check the four cases for acuteness. And there's one solution here and then a second solution here. Let's see what happens here. Practice 3. In triangle ABC, angle A is 39 degrees, side length A is 14, and side length B is 10. Determine the measures of the other side and angles. Express your answers to the nearest unit. Okay, let's go ahead and do this. So the first thing we have to do is we have to write down what we know and what could possibly happen. First of all, you are clearly, in this case, given a side-side angle situation. So you know that the ambiguous case is what we have to watch out for here. Okay, there might be multiple solutions. Let's analyze the information we have. I'm really checking back at these guys right here. And the reason I'm looking at these guys is because it so happens that I'm given an acute angle for angle A. I'm given 39 degrees. Okay, so angle A is 39 degrees. The first thing I'm going to check is if A is greater than or equal to B. Right? When you head back, that's the first thing you're going to check. If it is, which it is in this case, that means there's just going to be one solution. Right? Because we have 14 is greater than or equal to 10. That means we have one solution. One solution. Let's draw out this question. This question is from your textbook. And I'm quite surprised that there's one solution. I would have expected there to be two. But when you see this, you're going to be happy. Okay, that's the triangle we're looking at. It says to solve the triangle, which means we're gonna determine all the measures of each side and angle, and we're gonna do this using the sine law, of course. So right away we're given angle A is 39 degrees, and I think right away we could solve for angle B. Okay, since we have, yes, we can solve for that. We could certainly go like this, right? Which will be sine B over little b, which is 10. Sine of 39 degrees over A, which in this case is 14. Okay, I've solved this before, something like this before in your notes. We're going to multiply it by 10 on both sides and take sine inverse. And so we're going to have 10 times sine of 39 divided by 14. This comes out to be 27 degrees to the nearest degree. Now we have B, we can solve for angle C. I'll change colors. We're looking for angle C. That will be equal to 180 degrees minus 27 minus 39. 180 minus 27 minus 39 is 114 degrees. So to recap what we have 27 degrees here. We have 114 degrees here, which really represents how incorrect my picture is. Okay, because this is an obtuse angle. But that's okay. So really the picture will look something like this. It will open up and be something like that, where this angle is 114 degrees. But don't beat yourself up if your original drawing's incorrect, right? I'm doing this question for the first time. This is how I approached it. I realized the triangle is incorrect. But hey, that's okay. This side length here is 14. This is 10, which seems to be pretty accurate. Now this next side length, which appears to be, it's going to be the hypotenuse of this, should be the longest side. So we're solving for C now. Okay, we're solving for C. So it's going to be sine C. We can choose anything we want here. I'll deal with A to compare it. So C is going to equal to sine of C, which in this case is 114, times by A, which is, what's A, 14, all over sine of 39. Here we go. Here's the last thing we gotta do. And that comes out to be 20.3. But 20. Okay, so this is 20, which makes sense, right? This should be the biggest side, and we're done. Now, you might be wondering, well, what the heck do you do if two triangles could happen? Okay, and let's take a look at this first one. So hopefully the previous question I just did made sense. But let's take a look at this first question. Now you can see the solution below, but I'll work through it right here anyways. In triangle ABC, angle A is 30, and A is 24, and B is 42. So again, A is acute, which implies you have to go through the four cases. Here, A is not bigger than B. The previous one is A equal to B times sine of A. Okay, so what you would do is you're going to look at this. Is this equal to B times sine of A? Right? Well, B is 42, sine of 30 degrees. Okay, what's sine of 30 degrees? We should know that one. That comes out to be a half times 42 is 21. 24 equal to 21? No. And so on and so forth. This question will have two solutions. You can check this next one on your own. You're going to realize that's not the case. And because b sine of a, of course, is 21. And it's asking you, is a less than b sine of a? But it's not. Right? It's still not less than it. Still not less than it. It's greater than it, in which case, if it's greater than it and less than b, so if b sine of a is less than a is less than b, which in this case we're basically saying is 21 less than 24 less than 42, and the answer to that question, of course, is yes. Therefore, two solutions. Here's our approach. This is how you're going to do this question very quickly. What you're basically going to do is you're going to assume that one of the angles will be acute and the other one will be obtuse. Here's how the two triangles will look. Okay, those are how the two triangles will look. The first one, we're going to basically find b. How we're going to do that is using the sine law. Okay, because we're given two sides and an angle. Therefore, we should be able to solve for the sine law here, or use the sine law. We have sine of a over a is equal to sine of b over b. I'm going to solve for b here. Okay. Sine of a is 30 degrees. A is 24 equal to sine of b, which is what we don't know. And b itself is 2. When you solve this, what we're going to get, sine times 30 times 42, right, divided by 24. Sine inverse of that, 61. 61 degrees. That's an acute angle. Right there, b is acute. When you look ahead and check our work, there you go, 61. Now, it's written out for you here. To find c, you simply have to use your trick with 180 degrees, right? You have two angles, therefore you can find the third one. Bam. Now you have three angles, you have two sides. You can use the sine law once again to find the missing side. And then you're done. One solution. That's one solution. Right? Completed. If I can write solution. There we are. But what's the second one? Well, like I said, the second one will look like this. Notice how angle B is obtuse. What we basically have here, you guys, is we have angle of 61 degrees for solution 1. Solution 2 is going to be over here. It's going to be obtuse. But we're actually, it's going to have the same reference angle as 61 degrees. Okay? That is the one step you have to do. Is to find the second one, you're going to consider it like it's in quadrant 2, like that picture said, and find the reference angle simply by going 180 minus 61. Sorry, I meant find the actual angle. You know the reference angle is 61. And to find this angle, you're going to go 180 minus 61. That's going to give you 119, which is angle B. The rest of the procedure is the exact same. You're going to go 180 minus the sum of the other two angles to give you C. Now you have, again, you have three angles here. So you should be able to use the sine law to get C, which is the second solution. And you can see here's a picture of the first solution, and here's a picture of the second solution. That's as hard as it gets. Okay? If there are no solutions, when you check at the start, then you're simply going to write no solution. So hopefully this makes sense. That's the ambiguous case. Something you should highlight in your notes, as you've probably already realized, is this slide right here. Very, very important. if angle A is obtuse, which we haven't gone over, you can see if A is less than or equal to B, there's no solution. If it's greater than B, there's one solution. Go through it exactly how I went through this practice problem like this. Okay? Once again, ask me if you have any questions.